Okay, let's continue on with these hyperbolas. So the hyperbola, just like an ellipse, has a focus point, but instead of sitting, inside the box or the ellipse, it's going to be sitting outside in between these parabola shapes. So we have to figure out how we're going to get it. So there's a relationship between those distances again, just like the ellipse. So this distance from here to here would be A, because that was left and right. Distance from here to here, up and down, that is B. And then the distance from the center to a focus point, that's the C value, just like it was for the ellipse. Anytime you're measuring from the center to a focus, that's the C. Well, just like the ellipse, we're going to make a triangle out of these two lengths. So we're just going to connect these two guys right here. Well, this blue line is actually the same length as this blue line. So now you have a right triangle, and we can set up the Pythagorean theorem in the way that we want to. So now C is going to go back to being the hypotenuse. So A squared plus B squared equals C squared. So you can solve for C. So C is going to be the square root of A squared plus B squared. And out of the two between the ellipse and the hyperbola, I kind of like this one better because you're just taking the two numbers in the denominator and you add them. You don't care about which one is bigger or smaller this time. You just add them up. Which is kind of nice when you don't really have to think too hard. All right, let's go ahead and try and graph this first one. So graph the hyperbola with the center, vertices, the foci, and the asymptotes. So if we look at our equation, you can determine right away which one it's going to be, if it's going to open left and right or if it's going to open up and down. So the x fraction, that's the one that's negative. So we know it's going to open up and also down. So our A value comes from underneath the x's, so that'll be 8. The B is still underneath the y's. And the C, let's go ahead and get that out of the way. Just take your two denominators and add them together. So it's you can kind of think of it like this too. If you struggle to remember between the ellipse and the hyperbola, you just do the opposite of the sign. So if that's a minus, you're going to add. For the ellipse, it's a plus, so you'd subtract. Okay, so if you add those together and root it, C is going to equal 10. So our center is going to be right at 0, 0. So right here at the origin. So we just go left and right by 8. Up and down by 6. We're going to make a nice box. I know it's pretty exciting to watch this. Left and right by 8, up and down both by 6, and then you can put in your asymptotes, just go corner to corner right through the center. Okay, so just based off of this, you can get your, I guess we should put the curves in. So it's going up and down. And that one. And there's your hyperbola. So your vertices, the vertices are the 2 points that the hyperbola actually intersects. So that would be the ones going up and down. So negative 6, 0, and 6, 0. The focus points, that's coming from the C. So the focus points are actually sitting up and down as well. So -10, oops, dang it, I totally got those backwards. Let's do 0, -6, and 0, 6. 0, -10, and 0, 10. And then your asymptotes, just follow that formula out. So y equals plus or minus the b over the a. So you'd have 6 over 8, which reduces to 3/4, times x minus 0 plus 0. So just plus or minus 3/4 x. Okay, so there is a lot going on. So it is a little bit time consuming, but it's stuff that's not incredibly difficult to do. All right, so let's stop this video here, and then we'll continue with some more hyperbolas in the next one.